So now we're going to find the slope of the tangent line at a particular point. So at the point 1, 3 in this case. And we're looking at the function f of x equals 3x squared. So I first have to find the derivative, and then we can evaluate that to see what the slope is at that particular point. So we're going to go through our 4 steps. The first one is f of x plus h. So where there was an x, we're plugging in x plus h. So I need to square that. So x squared plus 2hx plus h squared. And then I need to distribute that 3. So I get 3x squared plus 6hx plus 3h squared. My second step is to take f of x plus h, which we just found, and subtract f of x from it. So I get 3x squared plus 6hx plus 3h squared. And I'm subtracting the original function, which was the 3x squared. So the 3x squareds cancel each other out, and I'm left with 6hx plus 3h squared. Step 3, take what we got in step 2 and put it over h. So 6hx plus 3h squared over h, I can factor that. And then the h's simplify out. So now I'm left with 6x plus 3h. And then my last step is to take the limit as h goes to 0. So we can do a direct substitution. So that term just becomes 0, and I have 6x. Now that I have this formula, which is the derivative, I can take the derivative of any point I want. For this problem, we wanted it at the point 1, 3, so I just have to plug in 1 for x. So the slope at the point 1, 3 is just 6 times 1, and it gives us 6. And the last example I have, I want to find the equation of the tangent line at the point 1, 3/2 of y equals 3 over 2x. So I'm going to have to do the same thing as far as finding the derivative first, but this time I don't want just the slope, I want the equation. So we're going to go to the y equals mx plus b form after we find what exactly the derivative is. So step 1, f of x plus h. So 3 over 2 times, in that instead of the x, we have x plus h. For part 2, we have to subtract the original function from part 1. For part 3, we're taking part 2 and putting it over h. And then part 4, I'm just going to put it up here. We're taking that limit as h goes to 0. So if h goes to 0, I get 3 over 2x minus 3 over 2x, which is 0. And then I get a 0 on the bottom. So I'm in indeterminate form. I'm going to have to algebraically do something so I can get it out of that form. So I'm going to multiply through by the denominators, the least common denominator of each individual term. So I have a 2x and I have a 2 times x plus h. So my LCD is going to be 2x, x plus h. And I have to multiply that on both the top and the bottom. So when you distribute this out on the top, the first term, the 2 and the x plus h cancel, so I'm just left with 3 times x. Over here, the 2x's cancel, so I'm left with minus 3 times x plus h. And it's all over h. So distribute that, we get 3x minus 3x minus 3h over h. So the 3x's cancel. And then, oh, sorry, it's not over h. It's over h times 2x times x plus h. My fault. And then the h here cancels with that h. So my final is negative 3 over 2x times x plus h. Now, when I take the limit as h goes to 0, I get negative 3 over 2x squared. So this is the derivative. That's the formula that I use to find the derivative at any particular point on the graph. So I'm just going to slide this up. So negative 3 over 2x squared is equal to my y prime. So I want to know the equation at the point 1 3/2. So first I'm just going to plug in 1. And I get negative 3/2. So that's the slope at that point. But we want to know the whole equation. So I'm just going to use the y equals mx plus b form. The y coordinate is 3/2. The slope is negative 3/2. The x coordinate is 1, and solve that for b. So I need to add 3/2 to both sides. And I get b is equal to 3. So the equation of the tangent line at the point 1 3/2 is y equals negative 3/2 x plus 3.